Alright, in this video we're going to finish lesson 1.2, and most of that is going to consist of looking at this idea of a weighted average. Now before I get to that first example, let's look right above there where I wrote down all these numbers. Pretend for a second that I did a survey of a class, and I asked how many total kids there are in their family, or how many siblings and that are in each family. And let's say these are the results that I got. And if I wanted to figure out the average number of children per family for that particular class, from what we saw in the previous video, I'd have to add all these up and divide by how many there are. Well, if I needed to add all these up and I had to type into my calculator 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2 plus 3 and so on, I might be concerned that, well, what if I didn't include all the 2's? What if I put too many in? What if I made a mistake? So that's a lot of the same number. So a faster way, or possibly a better way to find the average here would be to do this. Would be to say, okay, I have 3 1's, and I have 5 2's, I have 6 3's, I have 2 4's, and I have 1 6. And so I could type it in this in my calculator instead, and then divide by how many there are. Well, doing it this way is what we call a weighted average. Because what I'm doing is I'm giving a weight to each number. So for the number 1, there was 3 of them, so my weight would be 3. For the number 2, there's 5 of them, so my weight would be 5, and so on. And if I didn't see that list of numbers, if I just saw what I have here as my fraction, if I wanted to figure out how many total people there were in that class, I would add together the total weights. The weights would be the 3, the 5, the 6, the 2, and the 1. If I add those together, I would get 17. So in a very simple form, that is what a weighted average is. Now, you're also familiar with the weighted average. Your GPA is a weighted average because each class could be given a weight. So, for example, in this scenario, it says in some schools, a student's GPA is calculated based on the weights or credits assigned to a letter grade in a specific class. So in Susan's high school, AP courses are weighted as 5 credits. Honors classes as 4 credits, regular classes as 3 credits, and electives as 1 credit. The grading scale below is used in her school. Okay, so we have the grading scale, and they just told us how many, and that's also illustrated there in the table on the right there in blue. So we also know how many credits each of those courses are worth. So an elective class would be worth 1 credit because there's probably not as much work in a keyboarding class when you compare it to an AP calculus class. You can think of an AP calculus class to be 5 times as hard. It's almost like taking then 5 of those elective classes. Now you're not really taking 5 of them, but in this scenario, the credit is your weight. So if we wanted to figure out if we wanted to figure out her GPA based on that report card there, here's how we would set that up. We would say that, all right, that keyboarding class that she got an A+ in, it's only given a weight of 1, or a credit of, so it's only worth 1 credit, and her grade point for that A+ would be a 4.0. So she would have 1 credit at 4.0. And then the AP Calculus, that's a credit of 5. And that's got a grade point, since you got a B- there, of 2.67. So we would continue doing this for each of her classes. And so since we're trying to find her GPA, we would want to divide by the total weight. In this scenario, the total weight is going to be the total number of credits that she took. And so if we add up all those credits, there would be 16 credits total. So we would divide by 16. And when you do that, you'd end up getting, well, the numerator, if we did that first, we want to do this in 2 separate pieces, you'd get 38.68. But then when you divide by 16, you get her GPA of about 2.42. So that would be her GPA. So her GPA is an example of what we call a weighted average. All right, so you should have, if you have my notes printed out, you should have this table. And I can't remember if I made the change, but if I didn't, make sure that you make that change that you see in green there of having Francis homework to be 84, but let's read what's going on here. So it says in a college economics course, suppose that homework counts for 25% of the grade, quizzes are 10% of the grade, and tests are 45%, and attendance is 20% of each student's overall grade. Frances and her friend Adam earned the following scores during the semester. We want to figure out who received the higher overall grade. So we look at that. So Frances got an average grade of 84 on her homework, 85 on her quizzes, 87 on her tests, and she was there 100% of the time. So she got 100% of attendance. Where Adam did really well across the board. 96% of homework, 94% on quizzes, 95% average on tests, but Adam didn't do as well with attendance. So we want to figure out for each of them what would be their weighted average for their total score. So I want you to do this. So you're going to be doing this twice. So to find a weighted average for Frances, I want you to find a weighted average for Adam. Now in this situation, if you're trying to figure out, well, what would be the weight? Well, the weight would not be the 84, the 85, the 87, and the 100. The weight is going to be the percentages. Okay, so those are the weights that were given each of those scores. Now you could change those, or not could, but you want to change those to decimals. So we never use a percent as a percent. Remember, we always change them to decimals. So I'll just briefly remind you that 25% would be 0.25, 10% would be 0.1 or 0.10, 45% would be 0.45, and 20% would be 0.2 or 0.20. So I want you to use those as the weights. So go ahead and try this one out. So pause this video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. So for Frances, you should have taken and found that she had a weighted average of 88.65%, and Adam had a weighted average of 90.15%. So him only attending class 70% of the time dropped his grade down there from where he was averaging mid-90s to a low 90. So that's another example of weighted averages. By the way, anytime we're dealing with percents being your weight, you should always end up with a denominator of 100%, which would be 1.0 as a decimal. So obviously dividing by 1 doesn't change the value at all. All right, let's end by looking at what's called a relative frequency. A relative frequency is a ratio. Okay, now if you've forgotten what a ratio is just simply a fraction. That compares the number of times the number of event, or times a number or event occurs to the total number of numbers or events. So let's look at an example to illustrate this. So here it says, to celebrate the opening of a new branch, a clothing store advertised that the first 200 customers would randomly receive free gift cards, valued at $5, $15, $50, or $100. An internal memo to the new store manager contained the following sentence. There's going to be 5 $100 gift cards, 10 $50 gift cards, 35 $15 gift cards, and the rest will be $5 gift cards. Well, the first question there is to calculate the total dollar value of the gift cards. Now, essentially what we're doing there is, well, the first thing we need to do is figure out, well, how many $5 gift cards are there? Remember, there's 200 customers that are going to get gift cards. So what you first want to do is calculate, well, how many gift cards are we aware of? So there's 5 $100, 10 $50, 35 $15. So if you add those together, that gives you a total of 50 gift cards that we're aware of. So that means if there's going to be 200 customers, that means there's 150 left over. So that means there's going to be 150 of them that are $5 gift cards. So I want you to calculate the total dollar value of gift cards on your own. So go ahead and take a second. So pause the video, pull out a calculator, and figure out the total dollar value of all the gift cards. All right, let's see how you did there. You should have gotten that the total value in the gift cards would be $2,275. Now, part B, it says create a frequency table and calculate the weighted average, like we did earlier. So let's start with the weighted average. So we already know that to find the weighted average, we already have the numerator, because the numerator would be just doing what we just did in part A. So we'd have a numerator of 2,275 divided by the total number of gift cards, which would be the weight. So if we took 5, 10, 35, and 150 and added those together, well, we know that that's going to be 200. So there's 200 gift cards. We want to figure out the average value of each gift card. We would divide those. We would get $11.38. Gives us the average value of those gift cards. All right, so now let's create a frequency table. That's what we have down here. By the way, we're not going to do parts D and E, so if you have my notes, you can scribble those out. But let's look at C here. So we have the card values. So we have $100 gift cards, we got a $50 gift card, we got a $15 gift cards, we got a $5 gift card. Now the frequency is how many times do each of those occur. So we have 5 $100 gift cards. We've got 10 $50 gift cards. We've got 35 $15 gift cards and 150 of the $5 gift cards. Now here's where the relative frequency comes in. I'm going to scroll back up a second here. Now remember, the relative frequency is the ratio. It's a fraction of the number of times an event occurs over the total number of items or events. So in this situation, we have a total of 200 gift cards. So the relative frequency would be to say, well, there's 5 for this first one. There's 5 out of 200. Now oftentimes it's easier because if we do a graph, or if we're going to illustrate these in any type of graph, we're not going to want to do it as a fraction. So I want to change this to either a percent or a decimal. So we'll just do this as a decimal. So the relative frequency would be 5 divided by 100 would be 0.025. So again, it's always the part that we're looking at over the total number of items. So there's 200 gift cards, so 10 divided by 200 would be 0.05. And then we would have 35 over 200, which would be 0.175. And lastly, 150 over 200 as a decimal would be 0.75. So if I wanted to create a graph of that, if I wanted to do a bar graph, I could say, well, for the $5 gift cards, there was, so again, the relative frequency was 0.75. Well, that's going to be up here halfway between 0.7 and 0.8. So if we're going to do this as a bar graph, I would have a bar going up to about 0.75. 15, that would be 0.175. So that's going to be way down here. So 0.175 is going to be about 3/4 of the way, so almost up to 0.2. 50 was 0.05. So that's going to be halfway between 0 and 0.1. And then this would be just, so at $100 gift cards, there's hardly any of them, so we just have just a small little bar there. So that is what a bar graph would look like. So that is the end of this second video, the second part. So again, the idea here is just to focus on making sure you understand how to find a weighted average and understand this concept of a relative frequency. So hopefully you took really good notes, and again, come to class tomorrow with any questions that you might have.